Now for this question, the question says that using superposition theorem, calculate the current in each branch. Observe this question. For the first one, direction was in the question, meaning the question came with direction, right? How the current of I1, I2, how they flow. But this one now, you don't have something like that. But just that the principle you applied earlier for question one, that's still the same principle, nothing is changing. I said that as far as superposition theorem is concerned, the principle remain the same. Use the same concept when you are solving your question. Alright, first thing first. We are going for first thing first. Consider your source EMF. Conclude the source EMF you are going with. Now observe, how many source EMF do I have here? Two. And they are what? 10 volts and 4 volts. Now the question is, which one should I consider first? Is it 10 or 4? 10. Alright, me considering 10, it becomes my case 1. Abi? Now, so it depends, it's your choice. You might start with 10, I might start with 4. At the end, you get the same thing. Alright, now, for case 1, considering 10 volts, right? Meaning this E1. So therefore, you have to redraw your diagram. Abi? Yes. Then you redraw your diagram. What do you have? You have this. You are repeating the same thing. Nothing is changing, but you won't include the 4 volts, the other source. This still remains 10 ohms. This is what? 2 ohms. Then this is 3 ohms. Then this is your 10 volts. Don't forget, always label your circuit diagram for sake of easy calculation. D, E, F. Now, having considered 10 volts, step 2 is what?
Step 2 is look at the resistance.
Alright, before looking at the resistance, we've not assigned, we've not indicated each current. We've not indicated current in each branch. So, as usual, let's say from the question, okay, let me use this. This should be my I1. Mind you can denote your current with whatever you want. You can use I subscript A, I, you get what I'm saying? But in most cases, you make use of I1, I2, I3 and the like. Okay, I1, on getting to this point, this node, it will split, abi? It will split to branch BE and branch BC. Then let's denote this as I2 and denote this as what? I3. So therefore, take note, the current I1 is the current flowing through 3 ohm resistor. Agreed, right? I2 is flowing through which resistor is I2 flowing through? 10 ohm. 10 ohm resistor. And lastly, I3 is flowing through which resistor? 2 ohm resistor. Alright, now from here, what will be the next step? Next step, what do we have? Consider your equivalent resistance in parallel. So what will be the resistance I'll be considering here? 2 and 10. Why am I considering 2 and 10? We have to omit the one that is having a source voltage in it. Okay, now from here now, meaning that I'm solving 2 ohms parallel to what? 10 ohms. Then applying the idea of your parallel resistor, your calculation of parallel resistor, it becomes, let's denote it as R. Then we have 2 times 10 over 2 plus 10. Then this is what? 20 over 12. So therefore, R is equals to what? 1.67 ohms. Abi? Right? This is any question so far? Hope we are not too fast. Let's work together, please. Let's try to bring those people behind. The what? Okay, you are now in the first class, Abi. We've explained previously. we've solved the value of R to be what 1.67 ohms. Now what's the next step? Withdraw your circuit. Abi? Now, by the time you withdraw your circuit, nothing is changing. Abi? What is changing is that you've calculated the value of 2 ohm resistor and 10 ohm resistor to be this. Meaning that's what you are going to substitute. Moving on, what do you have? You have this guy, you have this. What will be the value here? 10 volts. What will be the value here? 3 ohms. What will be the value here? R, which is what? 1.67 ohms. Then this is B, E, F, right? Now, doing comparison between this circuit and this circuit, what will be the value of current passing through this circuit? You not get my question. I said check this circuit. You know, each branch has respective current that we denote it as. You know, it is from this branch that I brought out this circuit. Now, I want you to check this circuit diagram. The current we have in this circuit diagram is what here? I1. That's it. Understood? No question. We brought this diagram out of this place, and from here we can see that it is I1 that is passing through it. So from here too, I will still write that I1. So I have I1 here. Any question? Now, because from Ohm's law state that V is equals to IR. Then make I the subject of the form. Yeah, let's do it together, please. I equals to V over R. Then this is what? What's the voltage? 10 over what? 3 plus 1.67. And this is equals to what? In decimal, what do you have? 0.86, 0.86 ampere, right? Please, let's work together. What's the final answer? 2.14 ampere. This is your first task. Now, next up, what do you have?
Our I1 is 2.14.
I1 is what? 2.14. You are here to know the value of I2 and I3. How do you work it out?
Now for I2, we are going to use this law.
There's what we call it. Implement what? Current division. And you know how it works. Now, let's use current division. The one you are not interested in should be your priority. Implementing current division rule, then I2. What do you have for the value of I2? Oh, first thing first, let's do it this way. Hello, listen. Now, from here, I2. What's the resistor for I2? What's the value of resistor? 10 ohms, yes. Now, I3, what's the resistor value? 2 ohms. Now, let's calculate I2. You are calculating I2. You make use of the 3. Then, you have 3 divided by 2. Sorry. 2 divided by 2 plus 10. Multiplied by 2.14. This is what? What do you have? 2 divided by 12 times your final answer 0.356 ampere. Then I3. What's I3? How do you go about I3? That be what? 10 over 10 plus 2 multiplied by 2.14. That equals to what do you have? 1.78 what? Ampere. All right. This is case 1. We've solved for case 1. We've seen how it works now. Now, but the new thing is that for case 2 now, the source EMF in this case is what? 4 volts. First thing first, your direction. But in this case now, pay attention when you want to assign direction. Pay attention to this source EMF. What we did earlier was that case 1 should go in this direction. Like this, like this, like this. Then case 2, like this, like this, like this. This was what we said earlier. But now, for this question, it will change. Case 2 will change. Ask me why. Why? Now observe your direction with this battery. This battery now, where is the positive terminal? Where is the negative terminal? You know, the longest side is positive terminal, meaning that your current is starting from here. Are you with? From the positive terminal. Any question on that? That's the principle, right? Now you are saying that my source current is starting from here, then you know gradually it will get to this node. On getting to this node, what will happen? It will split. By splitting, we have this. Now this becomes, let's denote it as here should be I4, this should be what? I5, and this should be what? I6. Can you now see the difference?
Yes.
So let's take note of that. Direction. Direction. If we've gone with the usual way, meaning this one, it will be wrong at the end. We have issue with our resultant current. That's what I just did there. I just solved it using this, and they actually noticed it from start. Are you with me? So that's how it works. Meaning that when you are assigning direction to your circuit using superposition theorem, assign your direction. Go and check the positive terminal of your battery. Any question on that? Check the positive terminal of your battery. You want to ask a question? Are you clear? Now let's implement what we do. From here, this is the first thing that we are going to do. Then step 2 says what? What's the next step? Solve in parallel. The resistor in parallel. What will be the value of resistor that you are solving in parallel here? Solving 3 and 10 in parallel. We know why we are solving 3 and 10 in parallel, because they are independent. There is no source voltage with them. So meaning that solving 3 ohm resistor and 10 ohm resistor in parallel, let's denote it as R. So therefore R is equals to 3 times 10 divided by 3 plus 10. That's equals to 30 over 13, which is equals to 2.307. Please don't approximate for me, like give me 3 decimal. 2.307. Yeah, I love that. 3.07, 2.307 ohms. Now this is for the resistor. I've combined this and this. I've solved them in parallel. I have to withdraw my circuit. Please, I'm begging you, always withdraw your circuit. Always. So that you will see a clearer solution of what you are doing. It's not saying you can't do it with your head, but always withdraw your circuit. Now from here, withdraw your circuit, then it becomes this. Abi, this is my R, and the value of R calculated. Then this is what? 2 ohms. This is what? 4 volts. Now I noticed that you are finding this difficult. You made mistake when you want to know the specific current flowing through this current. You can use this idea to learn it, or this logic. From here now, the resistor we solve parallel. What are the current flowing through those resistors? I5 and I6. Now, this circuit, obviously, I will have an answer for the current flowing through it. But I need to be specific about the current value, be it I5, I6, or I4. Are you getting what I'm saying? Yeah. But now, for easier understanding, just that the resistor you've considered, automatically the current is gone. It's not as if that's the standard, but you can use that logic to understand it. From here, I've solved 3 ohms and 10 ohms parallel, and the current in those resistors, I5 and I6, meaning that I5 and I6, they are out of it. Then automatically, any current value I get here becomes I4. You understand what I'm saying? Yeah. Use that logic to just understand like that. Instead of start looking at this thing and saying, which one will it be the value of current? Is it I4, is it I5, is it IC? Do you understand what I'm saying? Now let me change the question. What if I have I4 here and I have I6 here? Then the value of current here will be what? I6. He said that since you solve 3 ohms and 10 ohms parallel, automatically the current in them, they are out of it. Meaning I5 and I4 out. Automatically, the value of current here becomes I6. You understand? Always remember that logic. Use it to understand this concept. Okay, from here, let me change what we have here. This was I6 now, and this was I4. Meaning that, because from your Ohm's law, as usual, V is equals to IR. Call this equation 1. Then it becomes I equals to V over R. Call this equation 2. So therefore, the value of current in this circuit, okay, you can surely denote it, I4. Which is equals to I4 is equals to what? 4 divided by what? 2 plus 2.307, meaning 4 over 4.307. And this is equals to what? 0.928. Do you approximate for me? 0.9287. Let me tell you one thing about approximation. The more you approximate, the lower answer you get. That's it. That's what I have to say. The more you approximate, the lower answer you get. For this approximation I just did now, the actual answer is 0.9287. If you go with 0.9287 and another person is going with 0.9293, do you know the person that will get the closer answer? The one with 0.9287. You understand? So me, I don't like approximation. I prefer everything like that. Give me everything like that. You understand? It's not as if you won't get it, but your answer should be a bit different. And it's good to get the same thing exactly like the lecturer. You get it? So from here now, what's the value? 0.9287 ampere. Alright, I've been able to calculate value of I4. Now, using current division, solve I5 and I6. That's the next step. Right, using current division. Using your current division rule. My out there means my rule. Now, I believe you know how to solve that. So for I5 will be what? That will be what? 10 over 10 plus 3 multiplied by 0.9287. Then I6 will be what? Please, let's get the value of this. 0.7143. I'm okay with this. Although 3 doesn't mean anything, but let's go with this. 0.7143 ampere. Now I6, what's the value of I6? That's what? 3 over 3 plus 10 multiplied by 0.9287. Please give me the answer. 0.27. 0.2143. I'm having 0.2143 here. 0.2143 ampere. Any question? So far, we've calculated the value of current in each branch where we considered the first source voltage, and which was 10 volts, right? Yes. Now, when we use 4 volts, we've also calculated the value of current in each branch. Next up, what's the next thing I do? To superimpose. By superimposing, bring the two diagrams together. So if you are looking at case 1, you'll be looking at case 2 too. But if you find that diagram difficult, You can surely go back to your case 1, check the diagram, go back to case 2, check the diagram too. You understand? So now, should we superimpose it?
Yes.
Okay, now let's superimpose. You know the idea of superimposing. Draw the first one with a thicker if it's separated, there's no point in now drawing it again now. Let's just superimpose. Let's superimpose. Superimpose. By superimposing your case 1 diagram, draw it. Please, let me confirm this if I'm correct. Abi? What's the value of current here? This is 10 volts. This is 3 ohms. This is 2 ohms. What about this? 10 ohms. This is for case 1. From here, now let me draw case 2 just to differentiate between the two diagrams, between the two circuit diagrams. I'll use a broken line to draw this. Are you with me? Now, you are still drawing the same thing though. Okay, let me change the marker then. Then changing the marker, I have this. You are still drawing the same thing. This is what do you have here? This should just be 3. What do you have? We now have the volt. The volt to be what? 4 volts, 2 ohms. 10 ohms. Now you are not done. Assign your direction and label it. This is A. This is case 2. This is for case 2. Don't forget. This is A. This is A, B, C, D, E, F. Now, for the other case, which is case 2, this is also A, B, C, D, E, F. Now, apply direction. The direction. Now, let me explain that direction with this diagram, with the aid of this diagram. For 10 volts, this is the positive terminal B. Then the source current is coming from it. So I will denote it with I1. So I'm getting to this place. It's going to what? Split. Then we say this is I2, right?
Yes.
Then this is I3. Same idea for this second one too. This is the source current. It's going upward. We denoted it as what?
I4.
Let me bring that one here. We denoted it as I4. So I4 getting to this node B is going to split. So this was our I5, Abi. Then this was our I6. Then what is the next thing? The next thing is what? Calculate the resultant current in each branch. Now from here, before calculating the resultant current in each branch, let's list out all the values of current. What's the value of I1? The value of I1 is what? 2.143 ampere. The value of I2? 0.3567 ampere. The value of I3? 1.7833. The value of I4? 0.9287 ampere. The value of I5? 0.7143 ampere. Then I6 is what? 0.2143 ampere. Now let's get the resultant value. Come back to your diagram. That's what superimposing means. Now for case 1, branch AB. What's the value of current here? Okay, I won't say anything. Let's do this together. I1. And that's denoting what? I1. Alright, now I1 minus I5. I will get a value of current. and that value is for which resistor? 3. Let's check very well. 3 or 2? 3. Meaning that I3, which is equals to what? What do you call it? I what? I1 minus I5. And that's what? Check. That's 2.143 minus I5. 0.7143. What do you have? 1.4287 ampere. Approximately 1.429. Correct. Now, the next one is what? The next value of current. I of 2 ohms. Exactly. That's what I want to hear. I of 2 ohms. How do I get the I of 2 ohms? I3 minus I4, because this is I3, it is opposing the current of I4. So you have I3 minus I4, and that is equals to what? Your I3 here is what? 1.7833 minus 0.9287. What do you have, please? 0.8546 ampere. For the last one, I of 10 ohms. That's what?
I2 plus I6.
Yeah, case 1. Yes, it's empty because it's addition. But don't get it wrong. I2 plus it's not see if I6 plus I is correct, but go with that order. I2 plus I6. Substitute. What do you have? 0.3567 plus 0.2143. 0.2143. This is what? 0.57 ampere. 0.5 exactly. 0.571 ampere. Now, I want you to take note of this. The question might say is that from here, observe something. The same value of current flowing through this 3 ohm resistor. We got what do you have? 1.4287. It's still the same value that is flowing through this 10 volts. Abi?
Yes.
Now, for branch BE, we have a resistor and a voltage. The same value of current flowing through this 2 ohm resistor is still the same thing flowing through this 4 volts. But this one, we only have a resistor, and the value of current flowing through it is 0.57. What I'm trying to say in essence is that for those voltage that we have here, what if the question says that 0.8546 ampere flows through 4 volts? You now see there that discharging, or you see there charging. What does it mean? Hope you are getting the point. You are not getting it. Now, what I'm saying is that the way you've written current of 2 ohm resistor to be 0.8546, you can still write it as current of 4 volts. Abi? Why? Because they are in the same branch. So you can write it as current of 4 volts equals to 0.8546. Open bracket. Will it be charging or discharging? We will get there. Are you with me? Likewise, for branch AF, for H3, current of 3 ohm resistor, that we got 1.4287. We can write it as I of 10 volts equals to 1.4287. Open bracket, charging or discharging. Now, the question is, how do I know if it is charging? How do I know if it is discharging? Hope you are getting the point. Now, the idea is simple. To know if it is charging, obviously, I have a positive answer. Then it becomes charging. And that's it. You understand? Battery charge. Any question? Any question? So that's how it works. That's how it works. So far, I can confidently tell you that there's no question that you cannot solve as far as superposition theorem is concerned. If truly you understood what we did today, but if otherwise, you might still have it a bit challenging. But what I would advise is that solve questions. Solve questions. Practice make perfect. And have it in mind, nothing is difficult. Nothing is exactly. Once you put your mind to it, nothing is difficult. So that's the end of this class.
Thank you, sir.